finding the general or particular solution to a differential equation, it's important to understand that typically you do this with two different integrals, a indefinite and a definite integral. And more specifically, when you're finding particular solutions, you must need an initial condition. So when you're finding the solution to a differential equation, it's important to understand that solutions to differential equations is not a specific value or a set of values, but rather it's a set of functions. And also, when you're given these functions, it's important to understand that the first step into finding the solution is separation of variables. So the first thing you must do is separate your variables, because this allows you to move your x and y variables to a respective side. Then, once you have separated your x and y's, then you can integrate. Now, it's important to understand that when you integrate, you'll only have one constant, so one c on one side. So this is where you had plus c. Now, although it may seem kind of confusing that you don't add plus c to the y portion of your equation, it's still the same thing because the constant is still present for both your y and your x, but you're just putting it on one side. Now, integrating is where, depending if you're finding the general or a particular solution, is where this can split apart. Because if you're given a general solution, so we'll write G for general solution, then you go into step 3 of just solving for y. So this is where you just isolate your equation to y. However, if you are given a particular solution, right? We'll say P for particular solution. Then you can solve not you'll eventually solve for C, but you can solve for C right away instead of Y. Then after you solve for C, you can solve for Y. However, general equation, you'll still have that plus C because you don't know the initial condition. But when you're given a initial condition, then you know for certain what your constant is. Uh, Another thing to look out for when finding your general or particular solutions to differential equations is natural logs and square roots. When you're given a natural log, this can either be the natural log without absolute values, or you can have a natural log with absolute values. And then this is all based on the initial condition. Because sometimes you can have negative values that work within the natural log, or sometimes you cannot have negative values and you'll need the absolute values. But again, you should look back to your given initial condition and then see which one matches up with which equation. Similarly, uh, your square roots, right? Because you can either have plus square root of x or negative square root of x. But again, this heavily depends on your initial condition. Depending on whether your input produces a negative output, will dictate whether you should have a negative or positive sign on the outside of your square root. Now that we understand the steps, right? So we separate variables, we integrate, then we understand, are we given an initial condition? If we are, then we find the particular solution and solve for our c, then solve for y. However, if we're not given an initial condition, then we must just solve for y, and we'll still have that plus c constant. And then things to look out for is your natural logs and your square roots. And these will depend on your initial conditions. Okay, let's look at our first example. Example, we're given y prime is equal to 2x over y. What makes this specific example quite interesting from what you'll typically see is that we're using y prime. However, when you're given y prime, you should rewrite it as let me. You should rewrite this as dy over dx. Because dy over dx is the same thing as y prime, but we're just writing this in our x and y components that we do know. And doing this would allow us to separate our variables much easier. So from this, we can multiply both sides by y. This crosses out, and then multiply this. And we can also multiply both sides by dx and multiply this side by dx. So this gives us y times dy is equal to 2x times dx. Then we move on to our second step of solving for the solution to a differential equation, which is we want to integrate. Okay. We know that the antiderivative of y is going to be y squared over 2. Now we could add plus c, but typically you don't add it on the y component side. So the constant will be added on this second portion. And we have 2x squared over 2. Then we add our constant here. Now, this specific example doesn't give us an initial condition. So we know that we're not solving for a particular solution. However, we're solving for the general solution. So our solution will still contain the constant c. So we can proceed as everything is normal and just move on. Now, the the third step is to solve for y. So we can multiply both sides by 2. So this gives us y squared is equal to 2x, because these two just go to 1 and we multiply by 2. So we have 2x squared plus 2c. Now this is just a constant multiplied by 2, so this would still just be c. So we don't necessarily have to say 2 times c, it can just be written as c. Then we'll take the square root of both sides, and we're left with y is equal to the square root of 2x squared plus c. Now, remember, this is a square root, and one of the things we said to be careful for is a square root, depending on our initial condition. However, since this is a general equation, we don't know our initial condition, so we can just say plus or minus the square root of 2x squared plus c. Finding a particular solution to a differential equation is understanding the set of function you're given and write it in the terms that you know that you can understand. And then once you understand your given components, your given x and y components, you want to separate them to their respective side. So all your y variables go to one side and all your x variables go on one side. And then from that point on, you'll integrate both sides. And once you antiderive, you'll add a plus c. Then you have to understand whether you're given an initial condition or not. If you aren't, then you're solving for the general solution. But if you are, then you're solving for the particular solution. In your general solution, you'll still contain the c variable. However, in your particular solution, you will not. So if in this instance we were given an initial condition, right? And let's say our initial condition would have been 1 and 0. I don't know. Let's just say that. So that means if we plug in 1 into this, or if we go back here, or actually we can stay here. We're left with 0 is equal to, we don't know if it's going to be plus or minus the square root of, and then we plug in 1 into our x. This is going to be 2 plus c. So we can square both sides. We're left with 0 is equal to 2 plus c. We can subtract, which leaves us with c is negative 2. So then we have y is equal to, again, we still don't know if it's plus or minus just yet, 2x